My name is Rich Makadok, and I am an associate editor at Academy of Management Review. I recently wrote an AMR editorial, which will be published in 2022, about how AMR authors who use formal analytical models and simulations can make their research more accessible for AMR readers. In preparation for writing this editorial, I interviewed over a dozen of the world's best modeling researchers in the management field. And the editorial that I wrote combines all of their accumulated wisdom, ideas, insights, and experience. So if you use any kind of modeling to develop theory and are considering submitting your work to AMR, I urge you to read this editorial in order to learn about how you can make your work more accessible to AMR readers. In that editorial, I write about both the problem and the solution. On the problem side, I review 3 basic obstacles to accessibility that can make it difficult for a typical AMR reader to follow modeling-based manuscripts. And then on the solution side, I suggest 3 solutions that can improve accessibility. The 3 main obstacles to accessibility are undefined jargon, mathematical abstraction, and oversimplified assumptions. I won't get into the details here about these 3 obstacles in this video, except to mention that the editorial discusses 6 different types of oversimplified assumptions that might provoke confusion or resistance in the mind of a typical AMR reader. So I really encourage you to look at all 6 of those. The 3 solutions that I discuss in the editorial are verbalization, concretization, and visualization. And these solutions can alleviate all 3 of the obstacles that I mentioned a moment ago. In fact, in the editorial, I explain how these 3 solutions can be used in all of the different parts of a modeling-based paper, from the introductory framing through the assumptions and derivations, all the way to the predictions, conclusions, and discussion at the end of the paper. I also provide examples of published articles that successfully use each of these 3 solutions in each of those various parts of a modeling paper. So you can refer to those published exemplars as models for how you can apply these same 3 techniques. Next, let me briefly explain the idea behind each of the 3 solutions. The first solution, verbalization, really just means any use of common, everyday, natural language labels and explanations to help bridge the gap between the model and the reader. This approach can alleviate all 3 of the problems discussed previously. First, verbalization can help to eliminate or at least reduce the problem of unfamiliar jargon by replacing it with more easily digestible terminology. Second, it can also help to explain why the model needs its simplified assumptions and why these simplified assumptions may not be as restrictive or as odd as they seem at first. Third, verbal interpretations of mathematical expressions can make them less abstract and less opaque in a reader's mind and help the reader to come along for the ride, if you will, on the journey that leads from the assumptions through the derivations to the predictions. The second solution that I discuss in the editorial is concretization, making things more concrete, which is an antidote to abstraction. Now, abstraction is an essential part of any theory because theory is necessarily an exercise in generalization. But formal analytical models and simulations may make the level of abstraction more pronounced. The advantage of such abstraction lies in the model's ability to convey the essence of a general phenomenon with a bare minimum of moving parts. The disadvantage lies in the reader's difficulty with relating the model to reality. Concretization, making it more concrete, can counteract this disadvantage by using a specific example to embody a generality or to represent a generality, thereby making it easier for the audience to relate to that generality. In effect, like evoking a metaphor. Concretization may alleviate 2 out of the 3 problems I discussed earlier. First, in terms of the oversimplified assumptions, concretization may illustrate why these assumptions are useful, despite their oversimplified nature. And second, concretization can help make mathematical expressions more vividly realistic and less opaque in the reader's mind. Finally, the third solution that I discuss in the editorial is visualization. I use the term visualization to mean the use of any visual aid to illustrate some point related to a model. These visual aids may include not only figures of various types, such as graphs, flowcharts, decision trees, timelines, or Venn diagrams, but they may also include tables that spatially organize information, even if it's just ordinary text, into 2 dimensions. Visualization can alleviate all 3 of the problems that I discussed earlier. First, it can help to clarify unfamiliar jargon by illustrating the meaning of the terms in a graphical or spatial way. Second, it can also illustrate a model's simplified assumptions in a way that elucidates their meaning, purpose, and function so that readers will more easily grasp and accept them. And third, visualizations of mathematical expressions can make them seem less abstract and easier to follow. Again, there is much more detail about each of these 3 solutions in my AMR editorial. So if I have piqued your interest here, then I really encourage you to read the full editorial. I will just conclude here by saying that formal analytical models and simulations are here to stay and are likely to become increasingly prevalent tools for theory development across the entire Academy of Management. AMR welcomes this development, and AMR aims to be the top choice outlet for papers that use these tools in ways that fit AMR's mission. The guidance that I provide in my editorial is intended to help facilitate publishing those kinds of papers in AMR. Thank you.